Okay, so welcome back, and now we're going to do an example of an application. So in this example, we're going to model distance with time, and what this is modeling is the light of a police car, let's say. So here's the setup. So we have this police car, and so we're looking down, and this is an overhead view. So what we're doing is we're saying, hey, we're going to model, what this is modeling here is the distance the light travels along the wall from an equilibrium point, or from the 0 point here. So we're saying that the minimum distance, right? So this point right here, right across the street, or right across from the cop car, is a wall. And so we're going to say that the distance right across the street, directly across from the police car onto the wall, is the 0 point. Okay. And what we want to do is model the distance from that point along the wall that the light travels. And that distance is modeled by this function. Okay? So obviously, the distance from the 0 point gets longer, longer, longer as the light rotates, right? So the distance is, let's say, way over here, is going to get farther and farther away. So the distance shortens to a minimum, to the 0 point, and then it starts to get longer. So over here, let's say this is the negative distance and this is the positive distance. And so that's what we're modeling. So the first thing is we want to make sure that we understand what we have here. So A, our stretching factor is 5, and B, which is another, you could call it a stretching factor, right? It's a horizontal stretch or compression. So B is equal to pi over 4. But that tells us our period. Our period is going to be pi divided by the absolute value of B for a tangent function, for tangent and cotangent. And so then we have pi over, or divided by pi divided by 4, which gives us 4. So the period is going to be 4 seconds. Okay, now, the first thing that they're asking us is, how do we interpret the stretching factor, and how to interpret the period in the context of the problem? So the stretching factor here says that the light is going to travel 5 feet in half the period. So that means 2 seconds. So in 2 seconds, the light is going to travel 5 feet down the wall. Okay, or the distance, right? The distance it's going to go is 5 feet in 2 seconds. The period is telling us how long before the light spans the entire wall. Or in other words, you could look at it as one revolution of the police light. Okay? So because every time the police light does one revolution, the light is traveling way, way up here, all the way down. So basically going from infinity, negative infinity, all the way to 0 to positive infinity, right? Which is what the behavior of a tangent function does, right? So the light is going to cross the span of the wall every 4 seconds, is what it's saying. So now let's graph it. So again, we want to know where the asymptotes are located. So again, this is a tangent function. So again, where is tangent 0? The tangent is 0 at what? It's going to be 0 at all, it's going to be 0 at 0 and all multiples of pi. So it's going to be at 0 and 4, right? So again, they only want us to graph out the first 5 seconds from 0 to 5. So we're going to have 0 here. Okay, and it's going to then be 0 here at 4. Now the asymptotes are going to be halfway between that. So in this case, it's going to be at 2. Okay, the asymptotes are going to be at 2, right? So, okay, and it's also going to be at 6, but we're only graphing until 5. That's all they want. Okay? Because again, understanding tangent functions, the asymptotes are located at every pi over 2, or odd multiples of pi over 2. So that means it's going to be at 2, and well, what's another odd multiple of 2? Well, that's going to be 3, right? So 2, we're going to get pi over 2. Well, the next one is going to be 3 pi over 2. So how do I get 3 pi over 2? Well, if I have 6 here, right? If t is 6, then I get 3 pi over 2, and I got my other asymptote. So now, what's the behavior of this thing like? Well, let's plot a point. Remember, we can do the quarter points here, right? So here's a quarter point, right? So this, at 1, right? At 1, this is going to be pi over 4, which is a 45-degree angle, and we know that tangent of a 45-degree angle is 1. So we know we're going to have 5. So at 1, it's going to be at 5. Boom. Now, we also know every period, right? A period every 4 seconds, it's going to repeat. So at what? At 1 and 5, it's going to be at 5. So at 5 seconds, it's going to be at 5. Okay. So now, what else? Well, over here, right, at 3, it's going to be at negative 5. Because at 3, this is going to be 3 pi over 4, which is negative 1. Right? And so we're going to get negative 5. So this is going to be down here. And so we get our graph looks something like this, right? So it's going to right? Something like that. Okay, now, the last thing that they're asking us is, explain what's going on 1 second after, 1 second after, 1 second later. So they want us to evaluate f of 1 and then discuss the function's value at that input. So we already did that, kind of. We just have to interpret it. Okay? So we got 1, right? So this is 1 second. So f of 1 is 5. So this means that 1 second, so here's, again, here's t equals 0, right? If t equals 0, we're at 0, right? We're right across from the car. So we're saying 5 seconds later, how far did the beam move? Well, what this is saying is 1 second later, the beam moved 5 feet down the wall. That's what that's saying. And that's it. Have a great day.